We're running into some barriers when it comes to processing power. Processing power is measured in hertz, how many cycles we can do something in any given second. And we've reached kind of a peak on what we can do. And so we're having a hard time pushing past that peak. And so what we do is we do things like cores and hyperthreading, and there are other ways that we start creating ways to get more processing power. So in this video, let's take a look at processing power and how we get more processing power even though our speed of our chips are not really going up much. As we've seen over time, the number of transistors we have within our chips have been drastically increasing. But if you actually look at the CPU processing speeds, which is measured in cycles per second or hertz, what you can see is that we've kind of reached a plateau here. We see that we've started to exponentially grow, and then at some point in time, we've just kind of remained the same. And there are some really fast processors that are out there, but for the most part, generally what we use is stuck at this certain range that we've been stuck at for a while. And the biggest limitation to this is just the heat that it generates. As we increase the amount of processing power that a chip has and get it to go faster and faster, we have a problem because it's a small amount of area that's being passed this electricity and doing a large amount of work, and we can't dissipate the heat fast enough. So we've made increases with our speed, but we've increased the speed in areas that we've really brought the temperature way down. So if we bring the temperature way down and the environment that the processor is processing, then we can bring the speeds up, which is just not as feasible when you're talking about our machines sitting at home or in our businesses. So the speed is measured in hertz. What is hertz? It's cycles per second. So we measure how many cycles a chip can go through every second. And we typically measure it in like gigahertz. So let's give an example of 3 gigahertz, because that'd be a fairly fast machine nowadays. So let's say this is operating at 3 gigahertz per second. Then that means it's 3 billion cycles every second. And there's some sort of clock that will time this chip. And every time there's that cycle, it will do some sort of calculation. And it might have to go through many different calculations to be able to have some sort of output, but it'll go through all of these calculations before it gives that output. So there's some things that we've done to try to overcome these CPU speed limitations. So for instance, in some of our machines, we put multiple processing units so we can process more stuff at any given time. Or we've implemented hyperthreading, or we've done multi-core processing. So let's take a look at what those mean. But before we get into that, let's talk about what a thread is. A thread is some data that needs to be sent through and processed. So we have this line of code, or we have some data, or we have something that needs to happen that needs to get sent into the chip so that way it can be processed. So that would be a thread. So here's where that thread measures up with the hertz. As the thread goes in to be processed, it will take many cycles to do that processing. And how many cycles? It just depends on what that thread is trying to do. And then it will have some sort of output. So how do we increase the speed? If we were kind of stuck at the same speed, the same clock rate on these CPUs, how do we increase? Well, number one is we could just increase the number of processors that we have. So I can take this and I can duplicate it. I can have 2 of these on the same motherboard, or maybe 4 of them on the same motherboard. And so now I can process multiple threads at the same time. Another thing I could do is something called hyperthreading technology, or HT. Hyperthreading technology will take in multiple threads at the same time into the chip and able to process those separately and then have some sort of output to it. So usually it's like a couple threads that can go into this processor and be processed and sent out. Now, hyperthreading was invented by Intel, and so only Intel can really use that. And so really this is also called simultaneous multi-threading, or SMT, by any other vendor who's putting out the same technology. And then in 2004, we came out with multi-core processing. Multi-core processing is when we take one of these chips and we add extra components, duplicates of these components in here. So what it looks like right here is the core of this is duplicated, and now it'll accept 2 different threads. And notice that the outside is still the same here, and that's going to represent that there's still shared components among this. So this chip will have shared components, and then it will duplicate some of the components so that way it can take in more than one thread at once. So how can we increase the processing power of a computer? I'm going to give a little analogy of a freeway or a highway. And let's say the freeway is set to a speed limit of 70 miles per hour. That would be 112 kilometers per hour. So that is the top speed, and that's the top speed that the chips can process data. So we have some options here. We can add more lanes. That's what the multi-core CPU is. It's adding more lanes to the highway or freeway that we already have. What we also could do is build another freeway. So that is the multiple CPUs right there. The hyperthreading is more like letting people do the lane splitting and drive down the middle or use the emergency lane. And so this is using the emergency lane or other lanes that don't quite really exist, but we're going to sneak them in somehow. Now, just because we increase the amount of threads we can process at any given time doesn't mean that we actually are increasing the speed. It just depends on the scenario. So let's take a look at single versus multi-threaded applications. Let's say we have an application, and many applications are only single-threaded. So what they do is they need processing that needs to happen, so they submit the thread that needs to be processed. It goes into the chip and gets processed, and then the output comes out and gets sent back to the program. The program then figures out what's the next thing that needs to be processed, and the whole cycle starts over again. It's just a single thread that can be processed at any given time. So for single-threaded applications, we're kind of stuck at the speed of whatever the processor can operate at. Even if it can accept multiple threads at any given time, the application might not be equipped to be able to handle that. You have to have specific multi-threaded applications in order to be able to handle that. So let's just see how common these technologies are. Let's take a look at a PC versus a server. PC being, your desktop machine, your laptop, or maybe it's a Mac or whatever, and the server being something that's serving many different people. And so what we have with just our desktop machine, generally speaking, that's just one CPU running in there. We generally on our personal devices don't have more than one CPU that's running. Number of cores would be 4 to 6, and the hyperthreading just sometimes is incorporated into it, sometimes it doesn't. Some chips have it, some chips don't. With servers, generally speaking, with servers we have 2 to 4 CPUs, but there can be many more CPUs on a server. We could have the number of cores per CPU could be between 8 and 30. And it usually has hyperthreading, some sort of hyperthreading technology turned on it. So maybe with our desktop machine with 1 CPU and 6 cores, maybe we could just do like 6 processes, calculate 6 things at any given time. Versus our server, we've got 4 times 30, so that's 120 that we have there. Plus, we do hyperthreading, so maybe that's over 200 different processes that can happen at any given time. So why do servers need to be so much more? Well, number one is generally with servers, we have a lot more processes, a lot more programs, a lot more things that are running on a server than we do a regular desktop. Also, a lot of our server applications can be multi-threaded software applications. So they're designed for multi-threading. Not that like a lot of games and a lot of things are on desktops are nowadays, but it's more common for these server applications. And then it also has a lot of different users that have processes and things that need to be calculated at any given time. So the need to do multiple threads of calculation on a server is much greater than your actual home PC.